So let's move on to diodes now. What are diodes? Diode, these are the two terminal devices, okay? It's got two terminals. One is the positive terminal over here that you see, also referred to as the anode, okay? This basically triangle looking thing, this is the positive, and this vertical line right here, that's the negative terminal of the diode, okay? ID basically means diode current. Again, you got this positive terminal right here, and this is the flow of the current. One of the basic principle of a diode, it allows the current to go pass in one direction, okay? So it will just let the ID to flow in one direction. It's very almost, if you have a cell phone, you probably got diode in there, okay? It's almost in every device because you don't want the current to go reverse. So you have to make sure that you have got a diode in place so it does not damage your device. Diode ideally conducts in only one direction, as I was saying it earlier, okay? When you have a diode and the polarities are such that you have the positive terminal of the supply connected to the anode and the negative terminal is connected to the vertical line here of the diode, and it almost works as a short circuit. It will just allow the current to go past the diode, okay? But if I switch the polarity such that the negative terminal of the battery is connected to the positive terminal of the diode, and then the positive terminal is connected to the negative terminal of the diode, that is when it acts as an open circuit, okay? So no current will flow through it. So here ID is going to be 0, and here ID is going to be whatever, depending upon what kind of circuit is it. We can do Ohm's law and then find out that number, okay? So a very simple device, but very widely used and has a lot of applications. Now, these are some of the characteristics of the diode. On the left graphic that you see over here, which is the conduction region, okay? On the y-axis over here, you got the VD, which is the diode voltage, okay? And on the y-axis, the blue line is basically your ID, which is the diode current, okay? When the polarities are such that you got positive here, a positive terminal of the battery connected to the positive terminal of the diode, and the negative terminal is connected to the negative terminal of the power supply, that is when it works in a, as a short circuit. We also refer to it as a forward bias condition, okay? Forward bias, okay? There's no E here, so yeah. Forward bias condition. In the forward bias condition, because it's working as a short circuit, so what is going to be the current? The current is going to be maximum, right? We will call this current ID, okay, which is the diode current. Okay, now let's look at the non-conductive conduction region. This happens when we swap the polarity of the power supply. So a negative terminal of the power supply is connected to the positive terminal of the diode, and then the positive terminal of the power supply is connected to the negative. That is when you apply a negative voltage, you apply a negative voltage here. Okay, this is your negative voltage. And because in a negative voltage, the diode acts as a open circuit. Open circuit would mean it's basically disconnected, right? Something like this. So there, the diode current is 0. So there's no current flowing here. Okay, so it's just basically 0 here. So what do we learn from this? The voltage, if you look at on the left, the conduction region, the voltage across the diode is 0 volt. Okay, the voltage here is 0, and it will just basically simply conduct electricity, like shoot. The current is infinite. The forward resistance is defined as RF equals to VF over IF. The diode acts like a short circuit. And this situation that we hear is referred to as reverse bias, okay? The term reverse bias comes from the fact that we are supplying swapping the polarities, switching the polarities over here of the power supply. Okay, so what happens in the reverse bias region? Reverse bias region is basically a non-conduction region. It does not conduct any electricity. All of the voltage is across the diode. The current is zero. The reverse resistance is defined as VR over IR. Just simply applying Ohm's law, and the diode acts like a open circuit.